back. In today's video, we want to solve problem of the day from the Leetcode website. Leetcode, just like the Geeks for Geeks, is another platform that you can actually sign up with, and it's 100% free, and then you can practice your programming skills, right? So today is December 20th, 2023, and they've posted the question for the date, like the December 21st, basically. Let's look at the question that they have. It's this one in here, and it's rated as a medium difficulty question. Okay, let's open it and see what they actually want us to do. So the question says that given endpoints on a 2D plane where points I has basically two coordinates, xi and yi, return the widest vertical area between 2 points such that no points are inside the area. Okay, sounds good. And it's given a definition of the vertical area. It says a vertical area is an area of fixed width extending infinitely along the y-axis, and the widest vertical area is basically the one with the maximum width. Okay, sounds good. And it says that note that points on the edge of a vertical area are not considered included in the area. Sounds good. Okay, it looks very straightforward. And let's take a look at the examples that I have. It says if we have these 4 points, 8 and 7, which is obviously this point in here, 9 and 9, the one up here, 7 and 4 down here, and 9 and 7, this guy in here. It says the maximum or the widest vertical area is 1 because we go from 7 to 8, there is no point in between, and then from 8 to 9 there is no in between. So that's definitely the case. And then it says for the second example, the result is, for example, this guy in here, 3. And so let's actually code it. I'm going to Python 3, and they actually called it this name. So I'm just going to get this. So this is a function name, and it gets points as an input to the function. Let's start coding that. Just want to go define name of the function, and I'm passing in points as an input argument. So I don't really care about the y values, right? I only care about the x values. So the first thing that I need to do is that, like, again, there is probably like a lot of different ways to answer this question, but the way that comes to my mind is that I want to sort the data based on their x coordinate, right? And then do a comparison between each two of them. So I'm gonna go points the sort. I want to sort it. How do I want to sort it? I want to sort it based on the x values. So I'm just saying key is lambda x and x0, right? I want to sort them based on the x coordinate, which is the first index in x, because x0 is x, x1 would be the y values. Now that I sorted, I can go max width. I'm just going to set it to 0 and then just loop through all of them, right? I'm just going to go for I in range. I don't want to go 0. I just want to start from the first one because I want to compare it with the previous one, right? And it's 0 indexed. So if I start from 1, I can compare it to the element number 0, which is like the actual first element in the list. So I'm just going to say for this in range of 1 to length of points, right? I want to say width is points. I only care about the x value, right? So index would be 0. This minus, let's just copy this guy and put it here, but for the previous one. And I'm just going to go if w is greater than max w, then max w is double, just like updating it. You can do it this way, or you can basically just go max W equals maximum of W and max W. That's the same thing. It doesn't really matter. And then once it's done, you can just go return max W, right? Uh, so I coded this and I put it into my account up here, right? And that's the exact same code that we just saw. I ran it and it says that it accepted and runtime was this much, which means to beat, oh, cool, 99.79% of the users in Python 3. That's really cool. That's super cool. Memory, like, not the worst memory usage, but okay, like it's not the best actually up there. This is something that you can keep working on. Like you can actually try to reduce the memory usage and see like if you can come up with a better solution than that. Okay, that's about it. And it was short. Let's look at another one. Okay, this one looks hard. Well, at least it says it's hard. So let's take a look at this one. The acceptance rate is only 38%. So let's see. If we open this one, it says, here is a problem. Given two sorted arrays, num1 and nums2, okay, of size m and n respectively. So we have two arrays of different sizes. It says return the median of the two sorted arrays. Okay. And cool. That's interesting. So here it says, like, let's look at the examples. It says nums1 equals 1 and 3, nums2 is 2. And the explanation says the merged array is this, and the median is obviously 2. Okay. The second example says 1 and 2, 3 and 4. And the output is 2.5, which is the median, obviously. And which is like the average of the two values up here. Okay, this like should be easy to solve. Let's see. So they named it the sky. Let's go here and make a new function, define that. And we're passing in nums1 and nums2. Okay, cool. There might be like a lot of different ways to do that. But so they call it merge array and like they merge the arrays. Sounds good. We can do the same thing. I'm just going to go merged, for example. That's equal. So I have to merge them, obviously. So I'm just going to go nums1 plus nums2, right? And it's set up they're sorted, and after you merge them, you still want them to be sorted because that makes your life easier if you want to find the median, right? So I'm just gonna go sorted the sky. As you saw, like it's a different way of sorting. I showed it this way so that you see like there is more than one way. Like we did it like this up there, points.sort, and then here I just go sorted of this array, like make this, right? Like merge them and then sort them and then assign a variable name to the result. So that's the case. So now what I want to do, because if you saw in the example, when the length of the merged array is an odd number, the median is obviously the value in the middle, right? It's in here. And if the length is an even number, you just need these two numbers and you need to take the average, right? So that's what I'm going to do. I'm just going to go, for example, and the number of elements, right, is basically length of merged, okay? And I want to go if it's an odd number, so I'm just going to go if n mod 2 is 1, which just means an odd number. Basically, what we want to return is return merged and divided by 2, right? If you remember that, like this is the integer division. And so like 3 divided by 4 here would be 1. And because your 0 index 0, 1, 2 for this example that they had in here, so 2 would be element number 1, which is will be returning here. If you look at the solution that they have, like you have to put the solution in here, it says the function returns a float value. Okay, so I'm just gonna go return float value of this guy. Okay, and if it's an even number though, we have to find the ones in the middle. So I'm just gonna go call it read left, for example. That's obviously merged and divided by 2 minus 1, right? And just gonna go copy this and then go here. Mid right would be that, right? We can give it an example here, just so it's clear. So I'm just gonna go like, for example, I don't know, like 8, 6, 2, 5, 3, 4. How many? 1, 2, 3, 4, 5, 6. Okay. So 6 divided by 2, that's 3. So 0, 1, 2, 3 is this guy, which is the mid right. And then 3 minus 1, 2 is this guy. So we are selecting these two. As you can see, these are the ones in the middle. Well, this one is not sorted. We sorted the result up here after we merged them. But this is just an example, so you know that like this technique would work. So now that we have those, we can basically just go return the average value of these two. So this plus this, right, divided by 2. And then like you have to return the float. But if I go divided by 2.0, then it's dividing something by float value. Automatically Python saves that in a like returns the float value. That should be it, right? I think that's the case. And that's about it. I also tried this one here as well. This is the exact same question with the same solution that we saw. And I submitted my result, and it says that beats 82% of the users with Python 3 in terms of runtime. Memory, well, not so good, but it's always a trade-off. If you're using a lot of memory, then you have really good runtime. If you have a really bad runtime, it means that you're being a very, like your code is very memory efficient. The sweet spot would be something probably in the middle, but also like it really, really depends on the application and what you want to do, right? If speed is the case and people don't care about memory, then you want to optimize your code for speed and runtime. And anyway, it's really application dependent. You can keep playing with that and see if you can make it more memory efficient somehow. But I think that's it for today. Thank you for watching me. And hopefully these solutions were useful to you guys as well. And let me know if you had any questions in the comment section. And please don't forget to subscribe to my channel to support me and also to be notified when I upload a new video. You guys have a good one. See you all in the next video. Take care. Have a good one. Bye-bye.